Okay, I'm back, and now we want to talk about electrical resistivity. So far we have used seismic techniques, earthquake waves, to tell us what's inside the Earth. We have used gravity to tell us what's inside the Earth, and we have used magnetism to tell us what's inside the Earth. So now we want to use electricity to tell us what's inside the Earth. So let's first talk about the difference between a conductor and an insulator. A conductor conducts electricity. It allows electrons to flow through it very easily. So what would be an example of a conductor? Well, a metal. So in a metal, the electrons are free to move through the piece of metal. Water is also a good conductor of electricity if it's got some impurities. So if it's pure water, it's actually a bad conductor of electricity. But most of the time, water is always going to have some ions in it, like ions of calcium and magnesium, and so that is going to help transmit the electricity. So what would be an example of something that's an insulator? Well, just about everything else. So let's take, for example, quartz. Quartz is composed of silica tetrahedrons that are attached to each other. So the electrons are trapped in the bonds between the atoms of oxygen and silicon. So they're not free to be able to move around in the glass. So glass is an insulator. If you look at here, this shows the resistivity, which is the resistance to the flow of electricity for different kinds of substances. So the smaller the number, the better it conducts electricity. The bigger the number, the more resistive it's going to be. So if we look at clay, clay goes from 1 to 100. So notice 1 would mean it conducts very easily, and even 100 is conducting pretty easily. So what is it about clay that does that? Clay contains water, and we said that water is a good conductor of electricity. Okay, then you've got groundwater, and so groundwater can be a good conductor of electricity if it's got impurities, but the less impurities it has, the more it acts like a resistor. And then you can see that there are other kinds of materials typically found inside the Earth, and you can see what their resistances are. Notice for air, it has an infinite resistance, because if you got electrons over here, they can't jump across the air in order to get over to here. So air has an infinite resistance to the flow of electricity. So how can this be used to tell us what's inside the Earth? Well, one thing it could tell you is how much water is in the ground. So the idea is going to be that you're going to pound into the ground a metal rod, and then over here you're going to pound into the ground another metal rod, and then you're going to attach it basically to an ammeter. And then an ammeter measures electrical current. Okay, and then you also need to put a battery in there. So let's go ahead and put a battery right here. So that what's going to happen is that electricity is going to go from the battery into the ground, and then from the ground it's going to go back to this iron pole. It's going to go back up and then through the ammeter, which is going to measure the current, and then it's going to go back into the battery. So that's basically all there is to this measuring electricity thing. And if there's a lot of water in the soil, then that means the soil is going to be a better conductor of electricity, and so the reading is going to be higher on it. Now, what about, on the other hand, if you've got a crack? So let's say that you pound your iron things into the ground, and let's say that there is a crack in the the rocks so that there's like a fault in here. Well now, okay, so now let me get rid of this. It's going to be hard for that electricity, so let's say that we pounded our rod into that rock, which again would be very difficult, but let's just say for the sake of argument that we did. And the electricity comes out of the battery, but when it gets to the crack, it can't jump over to here. So what's going to be the reading on your ammeter? So it's not going to be registering much current. It might be registering a little bit of current if maybe there's some water in here, or maybe there's some soil that would allow it to make the jump. But the point is that you could detect cracks in the ground by using this technique. And I can remember doing this, and I can tell you from personal experience, when you are pounding these iron rods into the ground with your metal hammer, do not have a lab partner that accidentally or on purpose connected the battery to the iron rods, because I got a shock when that happened. So it wasn't very pleasant. Okay, so that's why I'm a theorist and I'm not an experimentalist. So I don't like going out in the field and doing this kind of stuff because I don't like getting shocked. All right, so let's take a quiz. Come back in our next segment and we will take a quiz over what you've just learned.